Hello students, welcome back to my YouTube channel Data Shah. I am starting a new series in which I'll be talking about the solutions of the system of linear equations. So there are various methods. There are direct methods and indirect methods to solve the system of linear equations. So I'll be considering all the methods one by one in this series. So first of all, starting this is the introduction class, and in this I'll be talking about the what are the simultaneous linear equations and what would be the different types of linear equations that we'll be talking about, and what would be the working rule to find out the solution. So let us consider a system of uh, m simultaneous linear equations in n unknowns. So this is very important. So n unknowns means we are talking about x1, x2 up till xn. So this is given by, so this is going up till a1n xn, which is equal to b1. Now, n unknowns, as I told you, that is, let me write x1, x2 up till xn. Similarly, we'll have another equation. It would be a2n xn is equal to b2. Now, how many equations we are talking about? We are talking about m simultaneous linear equations. So you will see here that it will go up to am1 x1 plus am2 x2 going up till amn xn is equal to bm. Now here you would notice one thing, that the a11, a12, a21, a22, am2, amn, these are all the coefficients of the unknowns x1, x2 up till xn. Whereas this side, the right hand side, that you can see b1, b2, b3 going up till bm, these are the constants that we have. Okay, so I can rewrite uh, the system of equations. You can name it as 1, can be rewritten as ax is equal to b. Now, what is A here? It would be a matrix A11, A21 going up till AM1, A12, A22. So this is your A. X would be the unknowns. So it would be, I'll just x1, x2 up till xn, and equal to b. B is nothing but your bi's. Now, let us consider the order. Now, what is the order of the A? A order is m cross n, m rows and n column. I think that would be clear enough. Let me write it again. M cross n. The order of capital X is n cross 1. And as we can multiply them, so this would be m cross 1. So I think this would be clear enough that you can multiply only those matrices whose rows and columns are equal. So here you could see the resultant matrix is coming out to be m cross 1. So let me just write where A is called the coefficient matrix. Um, and X are the, X is known as the, X is the, um, because it has one column. So it is a column vector of unknowns, and B is again a column vector of constants, right? Constants bi's. Okay. The unknowns would be xi's we are talking about. Okay. So now, how to deal with it? Whenever we talk about such kind of consistency of the system of linear equations, we talk about another matrix. So here we consider the matrix C, that is denoted by this, or it could be denoted by this. And this is known as the augmented matrix. This is called as the augmented matrix of the given system of equations. So its notation is given by so this is our augmented matrix, is called the augmented matrix of the given system of equation. Now, here, B is a column vector of the constants which is given to us. That means they are non-zero. Bi's are non-zero. So it becomes the non-homogeneous system of linear equations. When the Bi's are equal to zero, then we have a homogeneous linear equation. Now, I was talking about the consistency of this system of linear equation. Now, the consistency or the solution would exist, or we say that if it has a solution, then we say that the system of equations are consistent. Okay, solution can be unique or it can be infinite solution. It is possible. So the consistent system of linear equations means it has a solution. Inconsistent means it has no solution to it. Similarly, it holds for the homogeneous and the non-homogeneous. So let me just write that. So this is the augmented matrix. Okay. Now let me just write the types of the linear equations. So first is the non-homogeneous. Non-homogeneous linear equations. So if in equation 1, B is not equal to 0, that is B1, B2 up till Bm are non-zero, then such a system is called non-homogeneous linear equations. On the other hand, if we talk about the homogeneous linear equations, then in this case, we are talking about the if in equation 1, B is equal to 0, that is B1, B2 up till Bm all are 0, then such a system is called homogeneous linear equations. So this is the difference between them. And now let us talk about what is a consistent system and what is inconsistent system. So consistent system of equations. If the system has a solution that is either unique or infinite, but it has a solution, right? Then system is consistent. Whereas when we talk about inconsistent system of equations, so inconsistent would be just the opposite of this. That means if the system has no solution. So if the system has no solution, then the system is inconsistent. So we have certain working rules for this, and we can certain conditions, I could say, or the working rules to find out the solution of the equation. How we'll check what would be the conditions that we could find out whether the system is consistent or the system is inconsistent or not consistent. How we could find that. So let us talk about the working rules now. So let me take the working rule for finding the solution for the homogeneous. So for Ax is equal to B, I'm talking about. So for the homogeneous system of equations, what would be the working rule and what would be the different conditions that we have to look upon? Now, we have the coefficient matrix, that is A. We know about the augmented matrix, that is C. So we'll be talking about the various methods, the direct methods like Gauss elimination, Gauss-Jordan, we have matrix inversion, Cramer's rules. These are the various methods that I'll be talking about next in the next classes. So um, the working rule, let me write down. We write the augmented matrix and reduce it to an echelon form by applying elementary row operations. Then, right, then find the rank of C as well as A. Now we have different cases. First case, if the rank of A is not equal to the rank of C, then what would happen? Then in this case, we say that the system is inconsistent. So we can say no solution or inconsistent system. Second case, rank of A is equal to rank of C, and it is equal to the number of unknowns. So number of unknowns is basically n generally that we have. So then in this case, we have a consistent or you can see unique solution, that is consistent system. Then case 3, it could be that the ranks are equal. The rank of A is equal to the rank of C, but it is not equal to the number of unknowns, right? So it could be less than the number of unknowns. Then in this case, we will have the infinite solution case. So let me just box it. So we have infinite number of solutions. Again, the consistent system. Sir, I know you would be wondering how can we find out the rank and what do you mean by rank? So you can see that in my next lecture. So this is the working rule for finding the solution for a non-homogeneous system, that is AX is equal to B. Now, on the next page, I'll be talking about the working rule for finding the solution to the equation for a homogeneous set of the system. So let me just write it down. Working rule for finding the solution for AX is equal to 0. So this is our homogeneous system of equations. So in this case also, we'll be talking about the augmented matrix, and again, you will be calculating the ranks only. Okay, so I'll just write. So in the case of homogeneous, the rank of C is same as the rank of A. So this is always there. So we have consistent system of equations always. But we have two different cases where we'll be talking about the number of unknowns. Okay, so case 1 where the rank of A is equal to the number of unknowns. So if we have this, then there is a trivial solution. Trivial solution would be that you are having all the xi's equal to 0. So in that case, that means x1, x2, x3, and so on. All of them are equal to 0. So trivial solution means x1, x2, up till xn are all equal to 0. Now let us consider the second case where the rank of A is less than the number of unknowns. So in this case, we'll be having infinite number of solutions. So in both the cases, we'll be having a consistent system of equations for the homogeneous system. But the only difference is if it is equal to the number of unknowns, we will be having a trivial solution. That means all the xi's are equal to 0. And when we are talking about the another case, when it is less than the number of the unknowns, then we have the infinite number of solutions, or you could say the non-trivial solution. So these are the working rules to find out the solution for the system of linear equations. So in the next lecture, I'll be taking up what is rank, and then we'll moving ahead to find out certain questions, how you can find out the solution for the system of equations. So thank you so much.